Hi there, let's go over your topic 5 guided reading and questions. Let's do the definitions first. The first one is a electrochemical cell and what that might be. This definition isn't in the back of your book, so you should know that we need two different metals, which are the electrodes, surrounded by an electrolyte for it to be an electrochemical cell. Next, a battery is two or more electrochemical cells combined. And don't forget, we can hook those up. We can hook up batteries in series like this, which means then that we would add the voltages together. So if this was 1.5 and this one was 1.5, then the total would be 3 volts. Or if we hook them up in parallel with a wire like this going through them and then another wire, then what would happen there is it would only be 1.5 volts, but it would last longer. Let's keep going. Next, electrolyte or electrodes are two different metals in an electrochemical cell. It can't be the same metals. It can't be copper and copper. It's got to be two different metals. Next, an electrolyte is a substance that conducts an electrical current. The best electrolytes are acids and ionic compounds. Molecular compounds will not act as electrolytes. So if you remember, sugar solution wouldn't work. Pure water wouldn't work. These are all molecular compounds. Next, a primary cell is a battery or electrochemical cell that cannot be recharged, and a secondary cell is one that can be. Question 2. What energy conversions take place within an electrochemical cell? So from topic 4, we learned all sorts of energy conversions. So there's the input energy versus the output energy. And so the input energy in an electrochemical cell, of course, is chemical, and the output in our case would be electrical. So pretty simple energy conversion. So chemical to electrical. Next, why is it so important that they have a positive and negative? And so the hint here is if we go back to static electricity and the law of electrical charges, so in a wet cell we have the liquid in here. That liquid is the electrolyte, and then with these two rods are the electrodes, and electrons flow from the negative through the wire and they end up collecting at the positive. And so why does that happen? Part of the reason is the attraction of negative to positive. Okay, so There's an attractive force from the negative to the positive. Similarities and differences between the discoveries made by Galvini and Volta. So let's go to our book for a minute. Here's what Volta figured out. So this is a voltic pile. So Galvini believed, let's talk about Galvini first. He noticed, it was kind of an interesting story. He was operating with two different instruments, two different metals on a frog, and he noticed that the dead frog's muscle all of a sudden twitched, and he couldn't figure out why when the frog was dead. And what he realized was that the frog's tissues conducted electricity. So he had two different instruments, and the frog's liquid tissues became the electrolyte, and the electric current generated from that ran through the muscle tissue and caused the frog to twitch. Later, Volta showed that voltage could be generated without using living tissue, so he made what's called voltic piles. And so he had a series of different coins stacked up with, and in between them, sandwiched in between them, was paper dipped in kind of a salt solution. And then he would hook up wires here, and he found out that these voltic piles actually conducted electricity. So here's what it looked like. So he had two different coins, a penny and a nickel, and a saltwater solution paper. And if you keep stacking up these voltic piles, you can get a very makeshift battery. What are the necessary components to any electrochemical cell? We talked about this before. So if we have a beaker and we put a acid solution, or we put an ionic solution in here to act as, that's our electrolyte. So we need an electrolyte. And then we stick two different metals. One will act as, so these are metal strips. One will act as the anode, which is the negative part of the electrochemical cell, and one will act as the cathode, which is the positive part. And then, so the cathode. And then if we hook wires here, current will run through the wire. So we could hook up a bulb here and we'll get current running through. So in your book, here's what it looks like. There it is. So you have a negative electrode called the anode, positive electrode called the cathode. Electrons move from the anode through the wire and they collect at the cathode, the positive end. You need two different metals. So in this picture, it's aluminum and copper. And that's how it works. Number 5, explain what causes batteries to wear out over time. So let's look at our picture again to get a sense of this. So what happens is, if you look at this, the aluminum allows its electrons to leave and they collect here, and what happens is the aluminum ions so the aluminum starts to wear down, the aluminum strip in the anode. As well, the solution, the electrolyte, starts to break down and wear down. And so you get an eating away of the electrolyte as well as the electrode. So slowly the aluminum strip disintegrates and eventually it's gone. So that's what happens when they wear down. Let's go to the next page. Similarities and differences between primary and secondary cells. We already talked about this, but let's go. So if the cell can't be recharged, we call it a primary. And so the amount of chemicals it contains determines the total electrical energy. A D cell, AA's, etc. However, rechargeable batteries are secondary cells. And when we recharge them, electricity forces the ions to go back to the original position. So it's almost like you hit the reset button. So here are some different types of cells. So three primary cells, alkaline batteries, zinc carbon, and so the primary cells, as you can see, we can't recharge, and they're used a lot in flashlights. Zinc with air, okay, is really tiny, and so they're used in hearing aids and watches. Then there's a lead acid battery, which is a secondary cell, and it's used in cars and motorbikes and so on. And then there's a nickel cadmium, and it contains potassium hydroxide, which is a ionic substance. It's used in electric shavers, laptop computers. It's rechargeable many times. And then there's the nickel hydride, which is used, of course, in laptops, cell phones, and it provides more energy and it will be recharged and lasts a lot longer. So different types of cells. What are the differences between a battery used in a cell phone compared to a battery used in a handheld calculator? And which type would the Energizer Bunny run? So let's go back again. This diagram really helps you on in your textbook. The Energizer Bunny, who, if you've ever seen the commercial, wants to keep going and going and going, would probably want to use the one that lasts the longest, and that's probably going to be the cell phone laptop batteries, because they last several hours. Fuel cells, let's look at a video clip for you to understand how fuel cells work.
Oh, no. How can the batteries be dead already? I forgot to save. Dear Tim and Moby, I've been hearing a lot about fuel cells. What are they? From Austin. Fuel cells are electrochemical devices that convert a fuel's chemical energy directly into electrical energy. Since no fuel is getting burned, fuel cells generate power more efficiently than a combustion engine. And fuel cells give off water instead of carbon dioxide, so they don't cause the pollution that combustion engines do. Okay, let's back up a second. Combustion engines, like the one you find in a car, burn fossil fuels for power. You can watch our car movie to see exactly how this works. Burning fossil fuels produces chemicals like carbon dioxide, which contributes to pollution. Also, a combustion engine is only about 20% efficient. That means you're only getting back 20% of the energy stored up in the fuel. Yeah, that's a waste. Fuel cells can reach efficiency levels closer to around 40%. The most common type of fuel cell is powered by hydrogen gas. It's a little like a battery with a positively charged cathode and a negatively charged anode. Sandwiched between the anode and the cathode is the electrolyte, which is coated with a catalyst.